Welcome to lecture 2 in this series. The last slide we looked at last time around was the examples of full duplex transmission modes. So we carry on from there. We can look at an example of a full duplex transmission mode. Here is a diagram of a network card that transmits signals over pair 2, which is pins 1 and 2, and receives signals over pair 3, which is pins 3 and 6, is called a media dependent interface, MDI-NIC, network interface card. Right? So this is how the wiring would be in a normal network card. Now you may have heard of the term a crossover cable or a crossover NIC. In a crossover NIC, things are switched around. In this case, actually pair 2, instead of transmitting information on pair 2, it actually receives information on pair 2. So which is great, right? Which is the opposite of what happens in the previous case. So now it's receiving data on pair 2 and transmitting data on pair 3. This is exactly the opposite, and that's why the name is called crossover. So when are these different type of cables being used? If you connect a PC to a switch, if you connect your computer to a switch or a switch to a PC, you use a regular cable, right? You're transmitting on one pair here and receiving on the other pair. The reason being here is the switch already is wired in the opposite way. So it has crossover ports directly in there. So that means it can receive on the first pair that you saw there in the previous diagram, and then it can transmit on the other pair. So this is perfectly matched. So whenever you connect a PC to a switch or a switch to a PC, everything works perfectly, and you can use a regular CAT cable or category 5 cable, for example. We'll talk about categories of different cables at a later stage, but at this time it's pretty important to understand that if you're connecting a PC to a switch, you can use a regular patch cable. So a switch is a device that is meant to facilitate communication between two PCs on the same network. We will talk about hubs and switches and routers at a later stage. For right now, for this information here, we're trying to just look at the cabling information. And therefore, a switch NIC uses the MDIX specification, the crossover specification, which means the switch transmits on pair 3 and receives on pair 2, which is the exact inverse or the exact opposite of what happens on an MDI NIC on a PC. So that's why we can use what is called a straight through cable or straight through patch cable to transmit information. Now, if you're connecting different devices together, this is a very nice diagram that I'm going to be showing you in the next slide. So just to reiterate this fact here, this causes the switch to have a built-in crossover function. The wire does not need to cross the pairs because the switch will take care of it. Okay, so we don't need to use a crossover cable in this particular case. If you're connecting a PC to a switch, we use a regular, what is called a straight through patch cable. Okay. Now, when you're connecting different devices, whether you're going to use a crossover cable or a straight through cable will depend on the type of devices you're connecting to. So what we have outlined here on this particular slide is that we have a straight through cable, which is in blue, and we have a crossover cable, which is here in amber or orange. If you need to connect a PC, so let's look at an example here for PC, to a switch or a hub. So here we have designated switch L2, meaning to say that's a layer 2 device on the OSI model. We will discuss the OSI model soon. and then we'll be able to understand what does layer 1 and layer 2 so on mean. But at this moment in time, let's assume we just take it for granted that switches are a layer 2 device. It's a more intelligent device than a hub. Hub is a layer 1 device which is only physical in nature. Okay, and we'll talk about the differences of the different layers and what they mean. But for now, let's look at the PC itself. The PC connects to a switch using the blue cable, which is a straight through cable, right? So we don't need any special cables to connect a PC to a switch. Similarly, if we want to connect once again, switch to a PC, same thing, because that's conversely true, right? At the same time, if you need to connect the switch to a router, so this is in the same category, the PCs and routers are in the same category. If you want to connect a switch to a router, you need a straight through cable. You don't need any special cables for that. However, if you need to connect a switch to another switch or a hub to another hub, you can see there's an orange cable when you have to connect like devices, right? If you need to connect like devices, a switch to a switch, you need to use an orange cable, which is kind of a crossover cable. And many times, whenever you go to a place, most places will have a crossover cable in a different color format. Similarly, if you need to connect a PC to a router or a router to a router or a PC to a PC, for communication to take place, you once again need a crossover cable. Okay, because PCs and routers fall under the same category, while switches and hubs are different, right? Okay, so this shows you where you need to use a straight through cable versus a crossover cable. Mind you, in today's routers, they are very modern, and basically they automate, even if you use a straight through cable to connect to routers or PC to a router, they may be able to figure out that, hey, this is the wrong cable. It will automatically switch over from an MDI to an MDIX, which is automatically, it will cross over, and notice that it needs to cross over to make communications happen. Right? So they are more sophisticated routers in play in today's world. And same thing with the switches. If you connect a switch to a switch, it may be able to auto flip its configuration over at the switch level or at the port level to be able to make connectivity work without using any crossover cables. So what does a cable look like? The RJ45 cable, which is the registered jack standard 45, specifies the number of wires in the cable, the order in which they appear, and the usage are shown here in the physical conductor, right? Or physical connector. So this here is the T568A designation. There is the T568B designation. The wires are just color coordinated slightly differently, but the pairs do similar jobs, right? There is pair 2, which is pins 1 and 2 as we saw before. There's pair 3, which is 3 and 6 here. So it's 3 and 6, except the colors are a little bit different in nature. And then we have the pair 1 and pair 4. In a general sense, normally in, for example, 100 base T, like 100 megabits per second, you need only 2 pairs. Usually pair 2 and pair 3 will be used. If you use, for example, Gigabit Ethernet, then all the 4 pairs will be used. So just let's go over this process here. Notice that the only difference between the two standards are the colors of the pairs 2 and 3. So those are different. And pair 2 and 3 are used for communication in a 10 base T or 10 megabits per second, or 100 base T, which is 100 megabits per second. That's a category 5 cable. We will talk about categories of different cables at a later stage, but for now we will understand that we need a Cat 5 cable if you're connecting networks with these speeds. However, if you want to connect faster networks, if you have a Gigabit Ethernet at home, or in the enterprise, obviously many companies have Ethernet, Gigabit Ethernet at their enterprises, right? And you may even have it at home by this time. So in this particular Gigabit Ethernet, or even Power over Ethernet devices, use all 4 cables, which are known as Cat 6 cables, category 6 cables. So these are more enhanced cables. So make sure, depending on the type of speed you're looking for, you buy the right type of cable. Power over Ethernet we haven't discussed so far, but basically in some devices or they do some switches do support power over Ethernet. That meaning to say if you connect the cable to any device, it will actually be able to power the device using power over Ethernet. So meaning to say the device it is connecting to may not have its own power, but it is depending on power coming in from the switch. So that's power over Ethernet, right? For that as well, you need all the 4 pairs in place, right? Now let's talk briefly about networks. Now, in terms of networks, a network basically is a set of devices, often referred to as nodes, connected by communication links. A node could be a computer, could be a router as well, a printer, or any other device capable of sending and or receiving data generated by other nodes on the network. A link can be a cable, could be air itself, because if in the case of wireless networks, it's going to be just air basically, right? There's optical fiber, everything over the internet, over the whole World Wide Web, all over the world uses mostly optical fiber. Or it could be any other medium which can transport a signal carrying information. Now, when you talk about types of connections, you will come across different type of connections. So let's talk about those type connections. One is going to be a point-to-point connection in which one station links directly to another station. Or you can have a multi-point type of connection in which, for example, you have a link and there are multiple devices connected to this link. So this is a multi-point connection. So this was typical in the olden days when you had a mainframe and you had a link and you had basically T connectors here connecting the stations over. Point-to-point connection basically provides a dedicated link between two devices. In this particular case, the entire capacity of the link is reserved for transmission between those two devices, right? Because it's one point to point, there's nothing else on that connection itself. It's a dedicated link between the two devices. Now, most point-to-point connections use an actual length of wire or cable to connect the two ends. Other options, such as microwave or satellite links, are also possible. That could sometimes be in a point-to-point connection as well. For example, when you change television channels by your infrared remote control, that's a point-to-point connection between the remote control and the television's control system. Multi-point connections, basically also called a multi-drop connection, is one in which more than two specific devices share a single link. In a multi-point environment, the capacity of the channel is shared either spatially or temporally. In several devices can use the link simultaneously, which is full duplex, and it is a spatially shared connection. The users must turn half duplex. If users need to take turns, it would be a half duplex, it would be a time shared connection. But in most cases, people tend to use the link simultaneously, which is full duplex. Categories of topologies, we'll talk about this next in our next lecture. Categories of topologies in which we look at the mesh topology, the star topology, the bus topology, and the ring topology. Well, have yourself a great day, and we'll meet each other next time. Take care and have a wonderful day. Take care. Bye-bye.